Uh, I'm Don Bosco Durai. I'm the co-founder and CTO of Pravasara. In Pravasara, we do security and governance. Very recently, we announced a product called PAGE, which stands for Pravasara and AI Governance, which does security and governance for applications built in using GenAI. It does three things. One, it is the security for vector DB. The second thing it does is it does validation for prompts and replies, and with the option to do policy-driven redaction. And the third thing that we do is we do centralized observability. I'm going to hand it off to Alberto to introduce himself. Alberto.
Thanks, Bosco. So by means of introduction, I'm Alberto Romero. My background is in data engineering, big data, machine learning, and GenAI. I've spent the last 15 years building real-time platforms with a focus on streaming analytics and machine learning. And prior to my current role, I was an AI startup co-founder and CTO. The company was acquired by Aon at the end of last year. And I joined Citi beginning of this year as Director of GenAI Platform Engineering.
Thanks, Alberto. So today we'll be primarily talking about building safe and secure enterprise applications which are using GenAI. Alberto will give a little bit of a real-world example and some of the moving pieces within a GenAI platform. Okay. And I'll be mostly talking about the tools and some of the approaches to protect GenAI application. So I don't need to emphasize that within the last 1 year, how GenAI has actually changed our lifestyle. And what we know is that we barely scratched the surface. The innovations are happening at such a rapid speed that it's mind-boggling, right? It seems that the possibilities are endless. But those of us who are actually really writing real-world applications, we know the challenges. It seems as though we are driving at like 100 miles an hour, and while we are driving, we are changing the engine, we are trying out different tires and different controls, right? The LLMs are being released, are updated almost on a weekly basis. RAGs and vector DBs are becoming an integral part of any of our GenAI applications. And there are new concepts like plugins and agents and coming up. And it seems that we are creating almost an entire new programming paradigm. And with this speed that we are evolving and innovating, sometimes it's scary. Like, are we doing the right thing? Like the stuff that we are building, is it safe and secure for others to use? Right? And there's been numerous incidents. Like last year, the Samsung engineers, they pasted some source code into ChatGPT, and OpenAI used it for its own training the model, and that got leaked. The IP got leaked for other users. That's pretty scary, right? Now, even last month, like Washington Lottery had to take down the application which generated some inappropriate images, and this application was been running for more than a month without any incidents, and all of a sudden it just generated some image which was like not expected, right? Now this had to be taken out. Now, if you look into some of the generative applications like with generative text, at least I can think of you can use some sort of validation, but I still don't know how you can really protect or validate an image that is generated. But that's a problem for another day to solve, right? Today, we'll be primarily focusing on the building blocks for writing enterprise-grade GenAI applications. With that, I would like to hand it off to Alberto to talk about some of the real-world examples. Alberto.
Yeah, thanks, Bosco. So in terms of the risks that are introduced by this new paradigm, just to borrow Bosco's words, we could categorize them into three. First one being data exfiltration through exfiltration of personally identifiable information. For example, a user sending their own data across to an external model, or even exfiltration of intellectual property. Either way, so either the user sending that across to a model, to say OpenAI, or a user maliciously attempting to get intellectual property out of GenAI application by using malicious prompts. Second one, reputational damage. especially for public-facing applications, where a model and hence a Gen AI application might exhibit certain biases or stereotyping, discrimination, or rudeness in the outputs they produce. It can have a reputational damage to the business. And last but not least, adversarial prompting, sort of hinted earlier in terms of using prompts in ways that they weren't intended to be used, leading to things like prompt injection, where you could change the system instructions from the application, or extracting those instructions through prompt leaking or even jailbreaking by breaching the security limits set up by the application. So next slide, please, boss. So on that basis, just going to go through a practical example. This is an architecture that some of you may have come across or might be vaguely familiar, and that sort of represents a RAG architecture, where on the left-hand side you've got an ingestion and data management component. They use to ingest your data and then push it onto a data processing pipeline, where you transform, enrich, and then eventually chunk it and embed it into a vector database through an embedding model. And then you, at application level, you may have an application interface with a retriever on the back end that is doing similarity search on the vector database based on the prompts that it receives. It may even have a prompt repository with a set of system prompts that it uses, and then obviously a generative model to produce outputs. So on the next slide, you can see a more specific example. So say, for example, we want to build a natural language financial product performance analysis. In other words, a user can use this platform to, by the use of natural language, produce reports and charts on the performance of a certain product or set of products. We would ingest data from, say, financial reports or even product change logs or SEO updates from marketing, etc., etc. And we would want to have a level of version control, because we only want the changes, the updates to get into the pipeline, and give priority to those updates, so they get prioritized when the user queries the data. Then the data gets transformed, eventually chunked, embedded into the vector database. And perhaps you could also add in a corporate database with customers that the retriever also interacts with. You might also want to use an agent framework, where you have different agents. Say an agent is looking after all the marketing reports and producing marketing or building up all the marketing figures. Another agent might be looking into the financials. Perhaps another one is collating everything together and producing a result ultimately back to the user. So this model, you can see on this slide, that can actually impose a number of potential risks. So starting on the leftmost part of the screen, you've got a potential for a supply chain attack. Those are well known in the software industry, but in this case, you can perform a supply chain attack by just modifying the data that eventually makes it into the data pipeline. So you may be introducing certain paragraphs with specific content that may be not producing the desired outcomes for the application, or even contain inappropriate language, etc., etc. So all that data will get chunked and embedded into a vector database, and if it's part of a specific context, it will get returned back to the user. Second potential risk is model poisoning. Now, with model poisoning, it really depends on what models you're using, whether you're using someone else's model, or you're training your own model, or you fine-tuning your own model. In this last case, just by poisoning the data for training the model or for fine-tuning the model, you can actually change the behavior of the outputs from those models. Prompt tampering, which is a bit similar to your supply chain attack, where you have perhaps a version-controlled repository of prompts that may be tampered with by a user. Then at application interface level, you can have data exfiltration, so either a user inputting PII or attempting to extract data from the application, such as the system prompt. And that's sort of linked to prompt jailbreaking as well, where a user might be attempting to get out of the security boundaries of the system. And now on the next slide, we can see the potential controls we can put in place. First of all, lineage and auditing of the data that gets into your pipeline. You need to understand where your data comes from to make sure that it's not poisoned in any way. Model scanning is an approach to understanding and ensuring that models are not going to potentially produce undesired outcomes. You can also leverage input scanners or other mechanisms to control what prompts actually make it into the system. You can also leverage guardrails mechanisms by either training a small model. For example, the Berta is a great example for PII detection. So whenever a user is inputting any data, they can actually detect any PII, or using regular expression matching, for example. Either way, you can leverage things like tokenization to ensure that the PII components are replaced when they make it into the application. And then finally, prompt evaluators. There are various different ways of performing prompt evaluation. Popular one is GEval, which is a framework for advanced metrics that leverages generative responses and probabilities. But you can also do other simpler things like inputting canary words on your system prompts. So these canary words, if you observe them in the model's outputs, then someone might be trying to get the system prompt as an example, or just introduce some prompt injection awareness instructions in the system prompt. So the likes of someone might try to manipulate the instructions you've received, blah blah blah. And then the last one could be to store embeddings of previous attacks in a vector database and then performing similarity search on those prompts and hence detecting those attacks. So yeah, next slide, please. So those are the examples. And in summary, from a risks and controls perspective, before taking any GenAI application into production, you should really ask yourself 3 questions. First one is, do you know where your data comes from? And auditing and data lineage is super important. Secondly, do you understand your models for full provenance? We talked about model scanning, data lineage, again, for training and fine-tuning. And then open source models, which didn't mention, but I think is worth mentioning as well. There's an open framework, model openness framework, or MOF, created by the Linux Foundation, the Generative AI Commons, which I'm proudly part of. There's a paper, you've got the link in there, it's worth checking out, but basically defines 3 different categories of model openness, from sharing the model architecture, the model parameters, the weights, which is what most people tend to do, and then call them open source models, but they are not quite open source models. You just have the weights. You can't really get to that model just from the weights. Other categories like open sourcing the training code or the inference code, and then more advanced like sharing research papers, data sets, or the intermediate checkpoints from the models. So worth checking that out. And then the final question, how are you controlling the inputs into your application? Whether that's through tokenization, using guardrails, approaches, or prompt evaluators, and again, data lineage, which is probably the most important thing. Over to you, Bosco.
Thank you, Alberto. So I made up these 3 laws. Okay, I think the main point out here is we are sometimes so hung up with technology and trying to make things work and trying out different LLMs and frameworks and concepts that we actually sort of miss the fundamentals like safety and security and privacy, which are non-negotiable. It doesn't apply only for applications using GenAI, it's also for traditional applications. So this has to be very important, because if we can't make our product safe, right, then people will lose trust and they will not use it. The same thing goes for security. These are extremely important that we make sure whatever we build is secure, right? Privacy is another extremely important that we tend to ignore it till the last minute when it's too late, right? So I'm going to go through each of them in a little bit more detail, right? I'll start with safety. And honestly, safety is going to be one of the most difficult problem to solve, right? The reason is safety is very difficult to quantify. It's very perspective, right? Depending upon who your audience is, the level of safety that you need may differ. If you're building, say, a software or application for which will be potentially used by children's, then you had to be ultra secure, right? But if you're trying to build a software which is going to be used primarily by internal users and there are limited number, you trust them, then safety level could be a little bit lower, right? The another thing is there is an expectation that safety always has to be 100%, but it's also difficult to quantify what is 100% mean. And we all know that we cannot build any software which is 100%, right? Let alone GenAI application, right? And so the more important for us is to see how we can build a software which is transparent to the user and also give them the control that they are safe of using it. Like very recently, I bought a Tesla and they gave me like a 1 month free of self-driving. And honestly, actually does an amazing job. It actually drives better than me, right? But I'm not still not comfortable using it in high traffic or internal roads, right? So I have the option to switch on and off, and I will, when the right time comes in, if I continue using it, I'll decide to use it in a more, crowded place. But for now, I'm more comfortable with what it is providing. The same thing applies for applications that we are building, right? Safety, you have to make sure we are transparent, we are able to provide all the right constraints, give them the confidence that we are building a safe software, but at the same time, giving them the control that they can decide how they want to use it, right? So when it comes to safety, there's not a single tool that is going to solve. In fact, I don't feel it is even a purely technical problem. It's a technical, it's a technology, it is a tooling as well as people process problem, right? The LLMs will continue providing some of the primitive things to take care of, giving enough guardrails for us, but it's not going to be enough. So you will have to use various validation tools off the shelf, right? And these tools will come in different flavors. Like some of them will be focusing on the input validations. There will be other things which should go and do more advanced things, right? So you should be able to, you have to use multiple tools. And I'll go through a few of them at the end of the slides, right? The second is there's new things coming up, something called adversarial LLM. What this does is it has a parallel LLM which has been trained and built to challenge the response from the primary LLM. So if you are writing a GenAI application and the response comes back, generally this response is very unpredictable. Like if it's a database, if you're running a query, you will pretty much know what it is. You can have a CI/CD and testing automation to validate it. But in the world of LLM, everything is subjective, right? Even if you ask the same question, it may not come with the same answer. So LLMs can be one of the ways of even questioning or challenging whether the response is right or wrong, right? So there are some of them are coming in on the safety side. Meta released something called a Llama Guard 2, which itself uses Llama 3 to do some sort of validation. And the good thing about them is they actually are doing a very focused training for certain use cases, right? Now, the other thing, as I said, is also not about technology; it's also people and process. And without a human in the loop, is you're not going to definitely not going to succeed, right? So you have to trust but verify. So the other thing is security, right? Just like safety, security is slightly different. Basically, like if you look into today's even traditional software, like most of the time we spend on taking care of CVs and there are denial of services and cross-site scripting, all those things. All those problems gets magnified in the world of LLM, right? In LLM, like people can misuse it. There are malicious users can, similar to cross-site scripting, they can do prompt injection, they can do, as Alberta mentioned, there could be supply chain, issues. All those things has to be taken care. And we being, particularly GenAI being such a new thing, I'm sure every one of us might have just do a pip install some software without even realizing what it's going to bring in and what could be the challenges, right? So there's a lot of things has to happen to make sure that the software that we are building is safe and it's not causing undesirable actions, right? The LLMs, they claim and they may be able to solve some of the basic prompt injection and similar vulnerabilities. But the challenge is always going to be like the LLMs will not be able to do everything because some of those things are not that straightforward. Something which will keep on evolving, and so you will have to use some of the advanced tools to take care of it. And LLMs are not the only thing out there, right? You have RAGs, you have other mechanism of data. You have to make sure that every point where data is coming in or going out, you have to be able to control at that point, right? Then access control and audit is another very important thing. Every customer that I've been working on recently, they have multiple GenAI applications, and this GenAI application could be based on different line of businesses or for a purpose, and you have to make sure the right person has access to the right application. So let's assume you have an application which is which is built for HR. You have to make sure that unauthorized users are not accessing it, whether it is the models have been burnt in or they're using RAG. They have the similar challenges. And just like traditional application, you need to have the right auditing. Otherwise, you will not know how it's going on, right? With GenAI, there are some new challenges are coming in the picture, like RAG and VectorDB. This is also very unpredictable. The GenAI people can ask questions, and that will generate into some sort of a vector, which could generate into an API query, a SQL, or any other ways of getting data. So you have to make sure that even that is protected. Like if you take, say, VectorDB per se, like VectorDB, I consider it like a super database. You will have data from multiple data sources into one VectorDB, right? And now once you get into that, you may have data which will be confidential, internal, or other restrictions, part of the same VectorDB. If a user is trying to ask a question, and if you are not even realizing if you are referring to a data document which has confidential, which the person should not be seeing, then you're actually introducing some level of security of the challenges of that, right? So you have to make sure that you have the right tool to filter out RAGs and output for RAGs and other vector DBs. Privacy is another one. To be honest with you, I feel privacy is the most easiest to solve, but unfortunately, that's the last thing that we come to because we sort of ignore it, right, till it is too late, and then we try to scramble to fix it, right? And the primary thing about privacy, the reason I'm saying it's easier is if you control the input, the data, you can actually, it's much easier to control the privacy, right? Like let's assume, just to give an example, let's assume you have users from multiple, you have customer data, and they are from different countries, including European countries. Right? If you have requirement that that if your users who are outside the European country are accessing those things and you have to do the GDPR compliancy, if you filter it out, you're actually good. Right? Similarly, if you have marketing data or you have customer data and marketing wants to use it, and if you filter out those things, you can actually make sure some of the privacy things are covered. So, so from the tooling perspective, the LLMs and others will come with way to redact PI and everything, but they'll be not very useful. So you'll have to use other tools, including tools which can be policy based. Access authorization is still the same applicable for privacy. Also, you had to do it. And as I mentioned, RAG and DB also, you should be able to do rollover filter like concept within vector DB, so you can actually filter things out. Okay? Then coming to some of the tools, there are good news and bad news. There are tons of tools available right now. Almost a new tool is getting introduced every day. The bad news is there are way too many things. We just don't know which one to use. And so I'm not going to bias on any one of the tools, but I can talk about some of the things, like including ours, Privacy. Like we have introduced securing vector DB. We can do prompt and reply validation. We can do a policy-based redaction. We have an end-to-end observability, including audits, who has accessed it, even on the feedback, who has seen some of the actual responses. We do that. The Llama Guard, which was released like a couple of weeks too, looks very impressive. I have not tried it in the production yet. That we'll have to see what's going to be the cost of using it, not from the dollar amount, but since they use another LLM, there's going to be a latency and additional hop. And is it, when you're in the grand picture, is it going to be okay or not? Then NVIDIA has been there forever. The good thing about NVIDIA NeMo guardrails is programmable, so you can use it the way you want to. So that is pretty much what we had. You can reach me and Alberto by LinkedIn. If you want to try out Privacy, you can try it by privacy.ai, and please be willing to take your feedback.